So the third topic I'd like to talk about here today for CMPT 214 concerns the use of regular expressions. Regular expressions are going to be one of the most powerful tools you'll use in the UNIX environment. And in fact, it's associated with an entire family of programs that offer different default functionality and different sort of features, which can be, particularly collectively, extremely powerful. But beyond that, it's one of the most powerful and practical tools you'll learn about very likely in the course of your undergraduate education. The concepts we first talk about today and the particular skills, the capacity to compose together regular expressions which will capture certain patterns are profoundly helpful in diverse domains of activity. And they're one of the sort of features that you acquire in a computer science education that can make you a real virtuoso on a computer compared to people who kind of pick it up on the street. And even if you spend your life, say, processing data rather than doing programming, they'll be of great value to you to know these things. Okay. So what are regular expressions? Well, regular expressions are, very briefly and informally, sequences of characters that define textual patterns. A given regular expression will indicate a set of patterns with which it's associated, patterns of sequences of characters that it can match. Okay, most commonly it's within a single line of text that it matches. Sometimes it can span multiple lines. And this can be used for pattern matching. It can be used also for pattern generation. In fact, there's this duality between capacity to recognize regular expressions, which can be accomplished at a formal level with what are called finite state automata, or finite state machines is another way to put it, on the one hand, and techniques for generating regular expressions, for actually outputting them. And it can be used for either one. So regular expressions can be composed of, and commonly are, of normal characters. In fact, a given sequence of text, dog, for example, is a perfectly legitimate regular expression for most cases of text. But then there are these special metacharacters, characters that have special interpretation that, in a very powerful way, allow you to sort of successfully define up richer and richer patterns associated with characters and sequences. Now, the thing that's confusing here is that that when we define regular expressions, we do so with characters that are also, it turns out, used for file name patterns in the shell, for the sort of wildcards we've seen, things like $sign. Things like, but more to the point, asterisk, dot, etc. And these are troubling because there's some differences in how they're handled. So I should have taken back that $sign. We're talking about things like star, for example, or bracket syntax, etc. It's a somewhat different syntax. It's actually more powerful in general in regular expressions, but you've got to be careful as to kind of for which audience you're creating this little set of text with these special characters. Is it for the shell, or is it for tools which use regular expressions, of which there are many, 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 but including things like sed and awk, many programming languages, and in fact, this grep related tool, which stands for global regular expression, print the results. So globally look for regular expressions and print the results. Okay, so what is this grep tool? You've actually seen me use it a few times within previous classes or screencasts. from those classes. So it's a command line utility. It's one of the most common ones used in Linux and in Unix, and it has origins far back within Unix. And the basic syntax is you say grep, and you give it some options, and you tell it to look for a certain pattern, which can either come from the standard input or from contents of various files. Okay, and by default, it will try to match patterns in each successive line of these files, and if a match is found, it outputs that line to standard out. That is the entire line. Okay, so it tries to do a match. If it finds a match in a given line, output that line. Now there's other modes. For example, you can do complement of that. You can put lines which don't match, the names of files which match, or count the number of lines which match, etc. And there's this family of utilities that provide some of this sort of functionality. Okay, so what does a regular expression look like? How do we build it up? Well, in general, we'll have a character, a sequence of characters defining this regular expression. It will consist of a sequence of characters. And most commonly, a given character, say A or D, or DOG, for example, each of those characters just represents the character D or the character O and the character G in successive sequence. In other words, it stands for itself. But there's going to be certain special characters like star, or like the vertical pipe type symbol, used here in a different context, or like a plus, or like a bracket, a square bracket, or what have you, that are going to mean different things. At its most easy level, as I noted earlier, there's a string that is a sequence of these literals, and we have something like DOG, and that's a perfectly legitimate regular expression, and it matches very specifically strings, so lines within the input string that contain sort of print out lines within the input string that contain matches for it, and matches the occurrence of characters DOG anywhere on that line. In this case, it'll match the first occurrence. It can occur at the beginning of that line, middle of the line, end of that line, but it'll be matching the first occurrence of that. Okay, so it's matching a single occurrence of D, single occurrence of O, single occurrence of G, in that order, in that sequence. So for many of these examples, we're going to be using grep on a set of words, just to give a sense of how it works. And you may or may not know that under Unix traditionally, and under Linux as one example, there's a set of commonly used words, well, some not so commonly used, a set of English words which are available in certain locations as a file where each successive line is a word. And you can find that on your Unix distribution, your Linux distribution, under user share dict. There's a thing called linux.words. Okay, so we can grep for this regular expression. In this case, it's a sequence of literals, DOG, within linux.words. You recall the sequence, the sort of how grep works. You provide options. In this case, there's no options. There's a pattern. In this case, it's dog. And then you tell it to look in one or more files, or 0 or more files. In this case, we're telling it to look in a single file. So it looks for all words which have dogs in it. And I haven't listed all of them here, but you can see there's a variety. And as it turns out, linux.words is sorted alphabetically and in ascending order, so-called lexicographically. And so we get these words. Now, where is dog in these words? Well, it appears in different places. Here it occurs here. In this later one, it's a bit further on. Here it's back to the fourth place. It's going to print a line if it occurs at any occurrence of dog. It matches the first one. If it matches the first one, output that line. Boom. That's an example of how grep works. It's looking for occurrences of this pattern, as defined by this regular expression, in this file. Now, of course, this is a singularly uninspiring pattern. Where it gets much more interesting is when we use these special metacharacters. And these metacharacters have meaning in the structure of an expression. So dot means any character. Star means, well, repeat the last character 0 or more times. Vertical bar means you can use this pattern or that other pattern. So a little tilde, this guy here, means match the following thing at the beginning of the line only. This dollar sign means match the preceding thing only at the end of the line. And then we can have a list of characters here within square brackets to get it to sort of match successive characters in square brackets. And there's others as well. Now, again, I want to emphasize that these characters, you'll have seen them before as special characters in a different context, namely to the shell. Here we're emphasizing characters, these special characters, which are special with respect to the grep family of programs, the grep family of these command line utilities in Linux. And these regular expressions, again, are used extremely widely in a large variety of text editors, many other types of programs you'll find elsewhere, as well as programming languages. But bear in mind that we're using them here as regular expression, special characters. So it's good to put it in, for example, single characters. What does that mean? Those who are watching this for 214 should know. Single characters here prevent contents of the string from being interpreted by the shell. That is, being interpreted as if it needs to figure out some special meaning associated with this bracket. It's waiving that normal interpretation by putting these single quotes. So it's to ignore that this square bracket open means something special. Okay, so let's talk about these. I briefly noted them, but let's talk about each in turn. The first concerns the dot character. Maybe what I'll do is I'll stop it now and go with each of these as a separate